Hello students. So today we are discussing about low pass RC circuit. So this is low pass RC circuit. We have R and C here, and we put input here, and we get output here. So now the output will be this voltage across this capacitor divided by this whole. So we are putting this from KVL. Xc will be the reactance of this capacitance divided by impedance of whole circuit. Okay, by voltage divider rule we are getting this output voltage with respect to input. So afterwards after that how it will perform as a low pass RC circuit. So I've told you that first of all you have to check that for omega equals to 0 whether it what will the voltage of output voltage. So for omega equals to 0 we have what will be the xc will be the omega 1 by omega c plus 1 by if you particularly put it as here like omega c, and after calculating it, it will be like this. So if we put omega equals to 0, it will be 0 and output voltage will be 1. On the other hand, if we put omega equals to infinity, then output voltage will be 0. So in this case, what will happen for low frequency, it will output will be non-zero, and for high frequency, this is low frequency, and omega equals to infinity is considered as high frequency. So for high frequency, when omega goes to infinity, then it will be infinity, it will be पूरा infinite हो जाएगा और ये क्या हो जाएगा, zero हो जाएगा. तो output voltage, it means for high frequency this RC circuit will not pass. For high frequency it will block the high frequency and pass only the low frequency. So ideally it should be like that for low frequency from 0 to FC is the cutoff frequency. It will have in pass band, it will all the frequency between this will be passed by this RC circuit, and the higher frequency band will be in stop band and it will reject all the higher frequencies. So this is the basic principle of this low pass RC circuit. So ideally it will be like this, but practically what will be its this gain and frequency plot. This will be like uh, some, it will not just like that, it will sharply it will give the cutoff frequency, पर होता क्या है, it will give a slope, it will give a slope, and the 1 by root 2 time of maximum voltage, the frequency at which you will get this voltage 1 by root 2 of Vm, that frequency is cutoff frequency. Okay, तो हमने क्या किया, आउटपुट डिवाइड इनपुट, ये गेन है, गेन को हमने पहले निकाला xc डिवाइड बाय r प्लस xc for considering this magnitude of this. So this is a complex number r plus xc. So after calculating this magnitude we will get this, and for finding the fc cutoff frequency we have to put this gain equals to 1 by root 2, and we will square the both side, and you will get the cutoff frequency 1 by 2 pi rc. Okay, so also if we want to the phase difference between input and output, the phase difference between input and output will be from this V out by V in. From this we can calculate that this will be minus tan inverse omega RC. So for omega goes to 0 for low frequency, this phase difference will be 0, and for omega goes to infinity, this phase difference will be 90 degree. It means when high frequency will be there, then there will be a output and input will be out of phase. Output will be out of phase of that of input when high frequency is there, but at low frequency the phase difference will be 0. It means exactly the output will be reflected, output will get the exact replication of input without any phase difference. So it means input will be reflected at the output, because the phase difference between these these two will be 0, and in case of 90 degree it will be output will completely reject the input. And also at the cutoff frequency, what we'll have at omega equals to omega c, we all of you know that gain will be 1 by root 2, so it will be phase difference is 45 degree. So in this way we can easily understand that how it will act as a low pass RC, a low pass circuit. So mm, by going further in this circuit, what we'll have in RC circuit, this will the RC circuit, this RC circuit. So the output voltage will be this voltage across capacitor. This voltage across capacitor and output voltage are equal. So if you find out the current across this capacitor, this current will be equal to the current flowing through this resistor, because current is coming from only resistance and these two currents are equal. So we are equating the what will the current across capacitor and current across this resistor. So it will be C dVdt by dt equals to VR by R. So output voltage will be, this is output voltage. Output, you can also write Q by C, or output voltage will be capacitance voltage. So it will be 1 by C integration of I dt. So I will be, current will be voltage divided by resistance, and what will be the voltage, this input divided by resistance. So we will get this output voltage equals to 1 by C of, if we put this I here, so V in by R dt. So at last you can see that output voltage will be directly proportional to the input voltage. So in the RC circuit, so this low pass RC circuit will act as an integrator. Okay, so it will act as an integrator. So what we'll have, whatever you give the input here for in the low pass circuit, it will give the output of this integration of this input. So for example, if you give the input as impulse signal, the output will be step output. If you give the input as step input, then it will give the output of ramp output. If you give the input of square wave input, then it will have output of triangular pulse. And in the similar way, if you give the ramp, then output will be the parabolic output. So you can easily see that output voltage is directly proportional to input. So whatever the input voltage will be there, the output will be output voltage will be the output will be the integration of that input. So in this way it will act as an integrator. So there are some condition for ideal integrator. So for ideal integrator, this phi equals to tan inverse omega RC. So omega RC should be greater than equal to 50 degree, and this phase difference will be 85 degree for good integrator. So these are the condition for a good integrator. I hope you understand how it acts as an integrator and how it acts as a low pass RC circuit. Okay, so I hope it will as you must be clear from this phenomena how it will act as low pass circuit. If still some doubt is exist, then you can let me know. And in the next lecture we are going through this low pass circuit only, that how it will get the output if the input will be the unit step. So we will see it in the next lecture. Thank you very much.